I am Professor M.V. Malkanawar, Department of Physics, first grade, Government first grade, Women's College, Jamkhandi. Today we have to discuss BSc first sem, third chapter problems. Second chapter problems. That is problems on conservation laws. That is, the name of the paper is Mechanics and Properties of Matter, Session 16, Problems on Conservation Laws. See the first problem. A 2 kg mass moving with velocity of 10 meter per second collides with another body of mass 6 kg moving in opposite direction with a velocity of 2 meter per second. During collision, the two bodies stick together. Find their common velocity. Observe here, 2 kg of mass, m1 equal to 2 kg, moving with a velocity of 10 meter per second. v1 equals to 10 meter per second. Collides with another body of mass 6 kg, m2 equal to 6 kg, moving in opposite direction with a velocity of 2 meter per second. That is, u2 equals to minus 2 meter per second. During collision, the two bodies stick together. Therefore, the collision is inelastic. Because of inelastic collision, the two bodies moving with the same velocity. Therefore, v1 equals to v2 equals to v. We have to calculate. According to law of conservation of momentum, total momentum before collision is equal to total momentum after collision. m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. m1 u1 plus m2 u2 equals to m1 v plus m2 v. Now take v common, we get m1 plus m2. Substitute the value of m1 u1 and substitute the value of m2 u2. Finally, you get 8 equals to 8 v. Therefore, v equal to 1 meter per second. The problem is very simple. Now we go to the second problem. A bullet of mass 20 gram moving horizontally with a speed of 400 meter per second passes through a block of wood of mass 1.5 kg initially at rest on frictionless surface. The bullet comes out of the block with a speed of 200 meter per second. Calculate the final speed of the block. Given m1 equals to 20 gram, that is 0.02 kg, given equals to 400 meter per second, m2 equals to 400 meter per second, m2 equals to 1.5 kg, u2 0 meter per second, v1 equals to 200 meter per second, v2 they have asked. According to law of conservation of momentum, total momentum before collision equals to total momentum after collision. m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. Substitute the value of m1 u1, substitute the value of m2 u2, substitute the value of v1 v2. Finally, we get 8 minus 4 equals to 1.5 v2, v2 equals to 4 by 1.5, that is 2.67 meter per second. Now, we go to the third problem. An empty rocket weighs 5000 kg and contains 40,000 kg fuel. If the exhaust velocity of the fuel is 2 km per second, find the maximum velocity gained by the rocket. Neglect the weight of the rocket. Observe here, mass of the rocket is 5000 kg, mass of the fuel is 40,000 kg. Therefore, total mass of the rocket plus mass of the fuel 45,000 kg. Escape velocity of the exhaust gases 2 km per second. Vmax equals to asked. Maximum velocity of the rocket is asked. Initial velocity v0 equal to 0. Vmax equals to v0 plus v log m0 by m to the base e. V naught 0 plus V equal to 2, M naught 45,000 kg, M equals to 5,000 kg. So after simplification, log 2 into log 9 to the base e, 2 into 2.303 into log 9, 2 into 2.303 into 0.9542. Final velocity of the rocket is 4.395 km per second. A rocket starts from rest with exhaust velocity of gases 1.6 km per second. Find the ratio of its initial mass to the mass when its velocity reaches 10 km per second. Observe the solution. See the solution. V naught equals to 0, V equal to 1.6 km per second, V equal to 10 km per second. V equals to V naught plus V log M naught by M to the base e, V equals to V naught 0, V 1.6 log to the base e M naught by M, V equals to 10, 1.6, convert natural log to common log, that is 1.6 into 2.303 into log to the base 10 M naught by M. Log to the base 10 M naught by M equals to 10 divided by 1.6 into 2.303. Log M naught by M to the base 10 equals to 2.7129. Therefore, M naught by M equals to anti-log of 2.7129, that is 516.3. That is the ratio of initial mass to the final mass of the rocket is 516.3. Now we go to the next problem. A cell of mass 10 kg moving at 25 meters per second burns into two parts. One part of mass 4 kg moves in the original direction with a velocity of 12 meters per second. With what velocity will the other part move? Observe here carefully. A cell of mass 10 kg moving at 25 meters per second bursts into two parts. Observe here, M equals to 10 kg, U equals to 25 meters per second. One part of mass 4 kg, that is M1 equal to 4 kg, moves in the original direction with a velocity of 12 meters per second, that is U1 equals to 12 meters per second, that is V1 equals to 10 meters per second. With what velocity will the other part move? Observe here, mass of the body 10 kg, initial speed 25 meters per second. It breaks into two parts. One of mass 4 kg, that is M1, it is moving with a velocity V1 12 meters per second. M2 equals to M minus M1, that is 10 minus 4, that is equals to 6 kg. V, that is escape velocity of gases. That is they asked V2, what is the velocity of the other part? V2 equal to question mark. According to law of conservation of momentum, initial momentum mu equal to final momentum m1 v1 plus m2 v2. Substitute the value of m, substitute the value of u, you get 250. m1 v1 is nothing but 48. m2 v2 is nothing but 6 v2. Therefore, 250 minus 48 equals to 6 v2. 202 equals to 6 v2. Therefore, v2 equals to 202 by 6. That is v2 equals to 33.67 meter per second. Observe here carefully what they have asked. See the question number, problem number 6. A body of mass 20 kg, that is m equals to 20 kg, moving with a velocity of 10 meter per second, u equal to 10 meter per second, breaks into two parts. The larger part moves with a velocity of 25 meter per second. Assume that the mass of the larger part is m1. It is moving with a velocity 25 meter per second, that is v1. The other part is nothing but total mass of the body is 20 kg. We are assuming the large part, the mass of the larger part is m1. Therefore, the mass of the other part m2 equals to 20 minus m1. It is moving with a velocity of 12 meter per second but in opposite direction. Therefore, v2 equals to minus 12 meter per second. They asked the masses of the two parts. M equals to 20 kg. It is moving with a velocity of 10 meter per second. V1 equals to 25 meter per second. V2 equals to 12.5 meter per second. Assume that the mass of the larger part is m1. Then automatically the mass of the smaller part is m2 equals to m minus m1. According to law of conservation of momentum, mu equals to m1 v1 plus m2 v2. Substitute the value of m, substitute the value of u, you get 200. Then v1 equals to 25 m1. Then m2 equals to m minus m1, v2 equals to minus 12.5. After simplification, see what you get. (200) equals to 25 m1 minus 250 plus 12.5 m1. 200 plus 250 equals to 37.5 m1. That is 450 equals to 37.5 m1. Therefore, m1 equals to 450 divided by 37.5, that is 12 kg. m2 equals to m minus m1, that is 20 minus 12 equals to 8 kg. Thus, the problems are very simple. Thank you to one and all.